and welcome to another round of Waterwise Visual Science Communication Seminar Series. I am Sara Kobilka, and we are thrilled to have you join us today. It's always really fun to ask the same question at the beginning, which is, I love finding out where are people joining from. We already have an international room because Mike is joining us internationally. It's 2 a.m. for him, so we're going to all give him a little slack. If he goes loopy, we'll just kind of like pull him back in. So this is, once again, the Visual Science Communication Seminar that is put on every semester by the Waterwise team from the University of Arizona. Today, we have Mike Morrison, PhD. He's a designer and psychologist who is trying to speed scientific discovery by creating new, more efficient designs for tools that scientists use every day. He's most known for creating the viral Better Poster movement and YouTube cartoons that affect how hundreds of thousands of studies are communicated. Mike's been invited to give workshops on design and communication in many wonderful organizations, including Harvard, Stanford, the U.S. Center for Disease Control, Microsoft Research, Johns Hopkins, and now the University of Arizona Waterwise VIP team. He's going to add that to his bio, I'm sure. He is currently the lead user experience designer at Curvenote, where he helps design the future of scientific publishing. Basically, he likes helping people or helping you process complex information faster. So, Mike, thank you so much. I'm going to stop my share and let you take it away.
Thanks so much for having me, Sarah. That was an amazing intro. Is your dog still around? Can you hold your dog up one more time?
Yeah, she was ringing the bell, and now she is.
Has everyone here seen this trick? I feel like it's going to beat anything I can say.
Oh, okay. Ready,
right.
trick?
She goes back. Okay.
That's just the joy of working from home, is you can do magic like this.
Cool.
This is Shoya the dog's magic trick. Strangest dog you've ever seen. Best webinar you've ever been to.
So I just wanted to make sure everyone saw that with the most important first 2 seconds of my talk here. Cool. Thank you, Sarah. Okay. That was glorious. All right. I'm going to share my screen. This is amazing. Okay. Everybody see a blank yellow screen? Okay, cool. So now you see a wall of text of scientific articles, right? These are examples of real scientific articles. And I'm afraid that when people outside of science look at this, they think something like, wow, scientists are so smart to be able to process all of that information, or like it's so detailed and rigorous and things like that. And that's what they see. But when I look at this after many years of working with scientists, I don't see that. I want to sort of remind y'all, if you're working with scientists, like they're not aliens. Like I know one scientist who was a bartender before going into science. I was a website developer, right? Like I think Sarah, you said you were a journalism major, right? Before getting into science communication. Like we're normal human beings, right? With normal information processing capability. And even like I worked in a lab studying IQ for a while. And like the difference between like the dumbest and the smartest person in the room is not like 0 and 100. It's like processing 4 things versus like 8 things. Like the range isn't that much. The smartest person in this room still probably has to read things 1 thing at a time, you know, and like maybe they can process them faster, but it's like everyone has a limited information processing capacity. So when I look at this, I don't see like, wow, scientists are so smart. I see this. I see the 300-year-old scientific journal and that we're still doing this. This is one from 2010. So journals, these scientific journals put all of these on scientists that they have to follow. So while scientists might be bright and creative people, like they're constrained pretty severely by the norms of science communication right now and what they get hired and promoted on. It's this really terrible feedback loop. So I have another test for you. Okay. So I'm going to show you something and I want you to just feel it. Just feel like how much it makes you feel like the magic of science. You ready? This is it. How much does looking at this make you feel like a sense of magic and wonder at science on a scale of 1 to 10? Like, put it in the chat. 1 to 10. How magical and wondrous does this feel? Let's see. I'll look at the chat. 1, 0, 2. That was generous, Dee. 3. Nice, Gary. 1, 1, 2. Okay, 2. All right. I've had zeros allowed. Okay. Now I'm going to show you another one. Ready? This is developing a technology to track and predict the motion of insects. How magical does this feel? 100. DD went from 2 to 100. Nice. Um, isn't this beautiful? Like, I'll play it again. It's just a simple image, right? Like this is like, wow, like so beautiful. Do you know where I found this image? Supplement 2 of the same paper. Like you scroll down, you click supplemental videos, and then you click supplement 2, not magical video of insects being predicted, but supplement 2. Like, so it shows you that like, if you guys are designers, like as a designer and somebody who makes videos, my work is done. Like I could take that video, just throw some music on it, and then like edit it a little bit, right? Like scientists are capable of creating just the most incredible, emotionally moving like images in the world. They just bury them because the traditional system forces them to. So I want you to have that in your head as sort of like the guiding philosophy here is how can we close the gap between 0 to 2 and 100, right? In DD's ratings. That's kind of what my life has been about. And what I can do from you from here on out, if you're science communicators, is what I want to do. I think a lot of you have probably a lot of skills, a lot of design skills. Some of you are probably better designers than me. The best I can do for you in this next like 30 to 45 minutes here is give you ammo so that when you work with scientists, you will have science to back up what you probably already know is the right instinct. So from that, let's go from here. And you'll learn some design skills if you didn't have them already. All right. Lesson 1. Except for those first slides, you're not going to see pretty much any text on the rest of the slides in this talk. And the reason for that is something called multi-channel processing. Sarah was talking about this a little before the call. Basically, you have eyes, you have ears, and you have emotions. Those are separate parallel processing channels. So that means I can send you audio, like my voice coming through your ears right now, and you can see visuals, which is either the slide you're looking at or the work you're focusing on. And I can make you feel something, right? At the same time, without any sense of conflict. Here's what that feels like. So I need you to focus on the screen for a second. I'm going to do all 3 at once, all 3 channels, visual, verbal, and emotional. You ready? I'm a scientist, and I study forest fires. You see, like I can say it, I can talk about forest fires on big, tall trees, and they burn the trees down, and like there's no conflict, right? Like you can feel and see and hear that all at once, right? Now I want you to feel what it feels like when there's conflict. Most of the time with presentation slides, what goes wrong is there's a sense of conflict between either like the voice coming through on the verbal channel and the visuals or the emotions are in conflict. So the biggest flaw is usually trying to get people to process 2 things in the verbal channel. So my voice in your head right now is coming through on your verbal channel. If I throw text on a slide, that's coming through on your verbal channel too. So the kind of that voice in your head that reads text out loud to you is, if it's saying something different than my voice, then you boost cognitive load in a bad way. So I will need a volunteer for this next experiment, someone who is willing to unmute. You don't have to do anything complicated. You just have to read a slide. Martha, thank you. Okay, you want to unmute?
Sure.
Okay. So I'm going to show you a presentation slide, and I want you to just be like the reading voice in your head that just read it exactly as if you're sort of like paying attention to it and reading it, but like
And
out
so you
loud.
want me to read it out loud?
Yep, exactly. But
Okay.
no matter what I do,
Oh,
just keep
okay.
reading. Okay. All right. Okay, ready?
Yeah.
Okay, here we go.
Research program.
Okay,
Large
so I'm going to tell you a
coniferous
little about what
plant
I
line.
study. So I
Negative
really
impact
like I
reduction
really enjoy
strategies.
studying big tall
Subvocal
trees,
suppression
and
reduces
we talk about
comprehension.
how we
Orienting
can
effort
take those
increases cognitive
trees
load.
and try to protect them from forest fires. You see, like that's what a lot of slides feel like. Thank you, Martha. That was perfect.
Thanks.
Is if I say something different, yeah, that was a great job. That's good resistance. If I say something different than the voice in your head is reading, it creates this sense of conflict, right? And the only way to put text on a slide and make it work is to say exactly what's on the slide at exactly the time it comes up, which is like really hard to do. That's why I don't use text, because I'm just not good enough to be able to use it appropriately. So that's called subvocal suppression. So now you've learned 3-channel processing, and you've learned something called subvocal suppression, which is when you read text and like a voice is reading a different thing, it actually like prevents you from understanding it. The other lesson here is if you put text on a slide, because I know it's unavoidable sometimes, just shut up for like a second and let that voice in their head read it, right? I've even seen a TED talker do like a joke where the punchline was like a single word of text where she just like shut up and let the text talk, right? Like either you talk or text talks. That's the idea. That's the science. I'm not perfect at it. That's the idea. So here's your next lesson. Okay, this is going to be for the chat. In this picture, whose legs do you see first? Anybody in the chat? Oh, yeah, blue, right? Blue jeans, of course, right? Of course. Okay, within this 3 posters or whatever, which poster do you notice first? Probably the one in the middle, right? Within that middle poster, what do you see first? Probably the atoms TS12 promotes fibrosis or whatever, right? The high contrast area, right? I can probably predict that, right? And if I run machine like an AI predictive eye tracking on this, it can predict that. It knows what you're going to look at, including the blue pants. So I usually show this example, especially to scientists, to sort of kind of prove in a way that like design isn't just making things look pretty. There's an efficiency to it that like you can help people read and process something much, much faster. Martha, you can absolutely have my better poster design. This is actually the middle one, the later better poster designs. It's kind of like an actual poster on the left. Yeah, so this template is also available for free in a public domain. But anyway, so I show this example to show that like you can actually help people process information faster and more efficiently with the design. It's not just about making things look pretty. And in a big poster session, that really matters. This is a real poster session from science. It's a huge challenge to process that much information in the limited amount of time. It really is. That's kind of one of the things I work on. But it's sort of this broader challenge in science of how do you communicate complex information very, very quickly? Ellie asked, what's the eye tracking tool you used? That is iQuant. You can get a free trial. I think it gets a little expensive from there, but I would try it and tell them I sent you because they donate licenses to me so I can do this kind of stuff and show you this stuff. We want to get it to a point where you can run eye tracking on any poster that you upload to a conference. So we're working on that. I want to show you some examples of more of this eye tracking on posters to show you sort of how you can improve information absorption with good design. If you don't design posters for people, these same principles affect literally everything you design. So if you look at these 2 posters and we run eye tracking on both of these, incidentally, the poster on the left is a very typical scientific poster. You would see 1,000 of these at a poster session. It's the traditional design. It's existed since the 80s, or probably the 40s. The one on the right is the viral first generation better poster that I released. Some say it went too far. When I released the one on the right, about 70% of people liked it, 20% hated it, 10% hated like me personally for some reason. A lot of designers said it didn't go far enough. The scientists were like, goes too far. But its goal was completely achieved. When you run eye tracking on this, you can see that the poster on the left, the traditional design, what you're looking at when you see these hotspots, if you can see my mouse, like there's like a hotspot, people look at like the logo and like the side of this graph and they're all over the place. What you're seeing on the left is the eye doesn't know where to focus. It's kind of like all over the place, right? That is literally what visual clutter looks like. What you're seeing on the left on the traditional scientific poster design that has been used across science for 50 years is that it is extremely cluttered. You didn't need eye tracking to really tell you that, but like scientists do. They need to know that like, yeah, nobody, it's cluttered. It's seriously, seriously, ridiculously cluttered. And we just got used to it, right? The one on the right, you can see it's not perfect. It was my version 1, but it directs the eye dead freaking center, right? Like it just orients super fast. I think one of my favorite tweets about this design when it went viral was somebody snapped a photo of one at a conference and they were like, guys, we can argue over like what the specifics should be on this poster and what we should add. But I think the debate as far as whether it captures attention and communicates the main finding quickly is kind of settled or whatever. Like it's night and day. And you can see that in the eye tracking. This is the generation 2 better poster. So the idea here, and you'll see this in a second, is that after all the hate mail I got, now it changed my whole career. I got a lot of love from many, many universities. I've had conferences mandate the design on the right. I've had individual professors ban it. So it was sort of splitting. But the one on the right was the one I released to sort of calm the waters and sort of respond to the feedback I got from version 1. It includes more room for methods and big graphs, and it's designed in like an F shape, and it still gives you room for a big takeaway on the left. Yeah, let's see. Big chat from Alicia. Maybe you're getting to this. I trust data and I see your eye tracking data, but normally the traditional poster design is not only preferred by organizers, but sometimes demanded. Do we just buck the specs given to us or only push change when layout isn't prescribed? Yeah, I would buck the specs, Alicia. I would almost advise ignoring them because a lot of those conferences, and I work with conferences a lot, they want to see novel poster designs. They really offer the template on their website as just sort of like a guideline. Like the dimensions are important because those are informed by like what boards they rented, right? So you have to follow the dimensions. But the way I would view your poster is that like you have the space that they have given. And maybe you have to include like a poster number or something, but I would like race the rule book on that one. Like the first better poster ever, one when nobody knew what it was, one best poster in the whole show. And it's one of those things where nobody knows. Like scientists don't have any design training, conference admins don't have any design training. I would absolutely buck the specs. And we're working with conferences to recommend better and better posters. So a lot of them, like ASCO, the biggest cancer conference in the US, recommends the original better poster. And we have other conferences sort of recommending like modifications of it. I'm trying to push them to like, whatever you do, even my designs, just recommend them. Don't mandate anything because, you know, letting that creativity out, I think is really important. Anyway, really good question. Let's see, type A, that's fair. Yeah. I would channel that type A into just like being a little revolutionary. Here's another eye tracking. You can see that it kind of follows this F shape, right? So it's like the data is pretty clear. Like this isn't like a little bit better. It's like, it's not perfect again, but it's night and day in terms of directing your attention. Here we have real human eye tracking. This is a fun one. So the poster on the left, first of all, there's one difference between these posters. The poster on the left is ostensibly, by many, many measures, a better poster, right? Like it's designed by prestigious universities. It is designed by people who research visual attention. I would take it on top of most posters, including the one on the right, at any day, except for one difference. Can anybody say in the chat what the difference is that might give the poster on the right an advantage in one area? I will take this time to caffeinate. I'm in Hong Kong. It's late. Title. Nice, Sarah. Yeah. Specifically, the title has negative space around it. And in terms of eye tracking and directing your eye, that is king because that's leaving space around something is like really on white space is where my brain went. Exactly. Yeah. Leaving space around something is really uncomfortable for scientists because they need that like density feeling. And if you do it when you're designing something for a scientist, I'm like, oh, it just feels too empty, right? But it's in terms of eye tracking and directing attention, the most powerful thing you can add to any design is empty space. And I'll show you the difference now in the eye tracking. So you're going to see human eye tracking performance. You're going to see 13 people wearing eye trackers and looking at both these posters. So I'm going to play the one on the left first. And what you're going to see is they're going to kind of dance all over the place. See how it just goes, they're kind of all over, right? Mostly reading the title, then they kind of pick a column and go with it. Again, great poster otherwise, just in terms of like better than the one on the right, constant it out, for sure. But the one on the right has a very clean title bar. Now watch this. What you're going to see when I play the one on the right is clear left to right movement. So when they do studies of what makes a design good or bad, one of the things they found is that on a good design, it encourages multiple people to look in the same order. And on a bad design, people look all over the place. So on the left one, again, dancing all over the place. On the right, we're going to see clear left to right movement, 13 people. Up, 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 up. It's real subtle, but just really these blobs just go clear left to right, like all of them. And then they go all over the place because the rest of the poster is terribly designed. But that title worked extremely well, right? Better than this one on the left from all the prestigious places from people who study visual attention, right? No shade, there's a great poster otherwise. But this just shows the importance of that negative space, right? So if you take one thing away, empty space. Fox, yeah, I think it's incredible. Like, this eye tracking stuff's great. Like, first time I saw it, I was like, oh, I'm done, right? Like, posters are solved. Now the long tail of convincing people. So this is one of the crowning achievements of my entire life besides my daughter. I'm going to show you real quick. I'm being half serious. So the eye tracking on this poster is going to do a magic trick. It's going to make 13 people read the entire top half of this poster at once in the right order. So this is like my record, getting people to look at 3 things. The magic of this poster is actually right here. If you can see where my cursor is, you see where it shifts from black text on white background to black text on gray background to gray text on gray background. That's 3 levels of background contrast: high contrast, medium contrast, low contrast. Your eye goes to where the most contrast is first. So by creating decreasing contrast and this Z pattern layout, watch this. Mood affects attention at work. Negative affect is distracting. They're learning. Right here. No one is down here. 13 people, nobody is reading the methods yet. So it actually properly directed all the eye movements in this sort of top Z pattern across 13 people. Then it scatters because I didn't design the bottom well enough. But it shows you again that 1, that you can do this, and 2, it's hard. Like this is my record is 3 consistent eye movements, right? So when you look at a poster covered in text and people, the scientists will be like, well, maybe if we align it better. It's like, no. It's like you're way past that. Like it's futile. So you have this other problem though. And this is a slide I messed up because it has too much text on it. This is going to show you a graph from simple to complex, from hate to love. And there's this problem where there's this curvilinear relationship where, play that again. If something's too simple, it's too easy. If it's too complex, it's like too hard and they hate it, right? But you want things that are just complex enough. I learned too late in my science communication career because I would design things like the posters you saw that were like really, really simple, and they communicate really, really well. They perform an eye tracking. You'd see them in person and then just like read them instantly, right? And people would respond so negatively to them. And I'm like, what the hell? They work, right? And it took me a long time to learn this. And I learned it from a paper actually, where simplicity and learning might be more linear, where like sort of the more simple and easy to understand something is, like the better you learn it. But simplicity and liking is curvilinear. It means that you want something that's like medium complex. And the way I solved this on later, better posters was like this first one just had the main finding in the middle originally. And then I added a graph, and like my hate mail went silent when I added that graph, because just having a big key figure just added a little bit more complexity. And then when I released the newer design, like with the sidebar on the left, the current one, this one right here, it was like 95% of people liked it. Even people that hated the first one were like, actually, I could get on board with that one, And I think it actually still has more content than people will realistically read, but it feels denser. It feels a little more complex, right? It leaves a little more room for that, even if it isn't purely efficient, right? Same deal with this one. And so I've had much better luck making things feel a little bit more dense and more complex than I naturally think is appropriate for the context, just to get that buy-in. Okay, we're going to try some basic science communication skills here. That was the poster demos. If you stay with me till the end, I will show you some of the bleeding edge stuff we're working on for scientific publishing and articles. So there's some basic kind of effects you can use in your designs to direct the eye really efficiently. One of them is a pop-out effect. Obviously, you see the yellow apple first. Our eye goes to where the most contrast is first, right? This matters a lot in poster sessions where you really want your poster to get noticed. People ask me in every single talk I give, like, what's the secret to getting attention on your poster? How to create an eye-catching poster or whatever. It's literally just contrast. Literally, you just want your poster to look different than the other posters around you. So as the science communicators, as the people helping these scientists design these posters sometimes, the best advice I can give you is to think of the row. Don't think of the poster. The race is the row, and looking at the poster as having contrast in the row. Pop-out effects, hot pink. Honestly, yeah, until people catch on, then you got to go. Yeah, exactly. I mean, like, get out your scissors, change the shape, put a light on it. There are a lot of rules that yet to be explored. This is a simple pop-out effect in graphs. Most good data visualizations will have one thing that pops out. Most of these effects for visual hierarchy, if you've heard that before, like if you look at this, what do you see first? The front tiger, the back tiger, then the tree. So when you think about making people look at something in a specific order, the science behind why that effect works the way it does is probably rooted in this evolutionary threat perception. you want to notice things that are more threatening than things that are less threatening. So if you break this picture down, if you remember this tiger picture, you can remember how to direct people's eyeballs. What does that front tiger have? It's bigger. It has a face, right? It has triangles, pointy little triangles, right? It's clearer. The back tiger still has a face, but smaller, less clear. Teeth, right? The pointy triangles. And then the tree, right? All the way in the back, no face, less colors, right? Like all of that is things you can use. A lot of times in visual hierarchy, you're just kind of hacking depth perception. And that's our level 2 is hierarchy. And now I have a game for you. So you've all seen this floating around the internet. Like this might seem magic to you. Some people are like, oh, it's like just these incredible designers who can direct your attention. If you look at it again, you'll notice that it's just size. It's just using that big front tiger effect. Big thing, less big, less big, less big. It's just hacking depth perception. And so now you're going to practice it. Okay, Sarah, can you send the link to, let's just start with game 2. So forget game 1, game 2. There's no time. Game 2 is more fun anyway. And I suspect you guys are a little more advanced. Cool. Okay, click the link to that Google Doc. You should see a mouse. You should see this very rudimentary scientific figure. And what I want you to do is I want you to left click on that first slide, left click and say duplicate slide. And then I want you to put your name in the bottom, like Mike's slide. No touching. Mine. You don't have to be as angry. I'll wait for everybody to create their own slide. So this is my crude recreation of a real scientific figure. And you guys were introduced just now, you might already know it, to the concept of visual hierarchy, which is the idea that everything you design should direct people's eyeballs to the most important information first, then the second most important, and the third most important. And, you know, I think one of my favorite design books says hierarchy is everything. I design things for scientists every day. And if you were to read my brain, 90% of it would be just thinking about hierarchy all the time. Where does the eye go first? Where does the eye go second? Where does the eye go third? So what I want you to do, now that you've got your own slide, is I'm going to give you some tips on how to get people to look at something sooner or later. And what I want you to do is use those to tell a story with this figure. So what you can find is you can manipulate the mouse, you can manipulate the background, you can change the colors, change the size, whatever you've got to do to tell a different story. Like, is the story about a mouse? What is this story telling? And in what order? So if I want to tell a story, if you look at mine of like the mouse, like is like a really special species of mouse that we're introducing, right? Then I might actually change the color of this stuff to have less background contrast, because background contrast gets attention. And so if I do less background contrast and just slow down everything else like this, just make it grayer on white, then the mouse stands out, right? And the story is about the mouse. But what's the second story? Is it about the mouse making a choice? So anyway, that's the game, is try to tell a story based on the order that you're going to make people look at things. Like mouse first, question mark first, jaggedy reading squiggly line, ECG first. What kind of story are you telling? So I'm going to start a timer for, let's go 3 minutes. Okay, 3 minutes on the clock. Anybody saw the show 24? You can hear that sound in your head, like a boom, boom. Okay. No rules, it's your slide. Do what you want to tell your story. But your first rule is, again, half the game is to make people look at something sooner. And the other half of the visual hierarchy game is to make people look at something later. So think in terms of speeding things up and slowing things down. This is the opposite of a scientist who tries to do like bold underline red. If you're doing bold underline red, you're trying to speed up, speed up, speed up. You're trying to use the red underline to surpass the bold, where it might have just been better to bold one thing and fade another thing out. That's lesson 1. You still got plenty of time, 2 whole minutes, and I might even boost the clock. Your next lesson is to use that background contrast. So your eye goes to where the most contrast is first. All of these slides have a white background, so darker colors are going to have higher contrast. If you change the background color, that rule changes, which means if you put a square behind something that's a background color, if it's different, you can change the contrast. So your eye goes to where the most contrast is first. Your next tip is size. Remember to hack depth perception. You still got 2 minutes left. So you notice big things before you notice small things. Your next tip is faces. So in order to get a face on that mouse, you might have to copy and paste from Google Images. That's okay. But you have an area in your brain dedicated to processing faces. And you notice things with a face really, really quickly. So if you put a face on something, it'll get it noticed. So background contrast, high contrast, then low contrast. Big thing, then small thing. Face, then no face. Another minute left, and then we're going to go through some of these. Another one is proximity. So if something's close to something else, if you want it to be seen right after one another, that's great. But if you want somebody not to see the thing right next to the thing they just looked at, you're going to have to slow that proximal thing way down or speed up something across the screen. You can move stuff around, by the way. 36 seconds left. As silly as this game is, it's kind of like a wax on, wax off thing, since a lot of y'all are Americans, hopefully you get that reference. What you're doing really is you're helping people process any scientific figure faster. You have 10 seconds left. Okay, I'm going to finish this point and then you're done. So scientific information is already very difficult. It's intrinsically difficult. So what we're doing here is we're not messing with the actual story at all, right? Like the story is the story. What you're doing is just telling the story faster and more efficiently. And that's what you're doing with a lot of this design for scientists stuff is you're not making the information any more easy. You're not dumbing it down. You're helping people process it as efficiently as possible, which is almost more important. Okay, pencils down. Let's go through some of these. I'm gonna go through them on my screen here. Okay, so this one is probably mouse has a reading, and then there's like this process to read it, and these are kind of equal almost. And then he has a question about the stuff. We're not sure what kind of structure to use in this experiment, but we're really sure that the mouse is gonna like have a reading of some kind of wave. This one has no hierarchy, right? We don't know what's the most important. This one is definitely the mouse is stuck in a single box and he's confused about it. And then see how the proximity effect is messing with it, even though this maze has less background contrast, it's around the mouse. So I see it next. And then there's some like debris over here last. So interestingly here, the thin line gives this less background contrast. So this is kind of cool. If you were to make that line thicker, it would show up first. This applies, especially this exact effect that prevented me from seeing that squiggly line first, applies to thin text. So thin text has less background contrast than text that is the same color but is thicker. That's why bold text works, because it just has more background contrast. Use that again, speed up or slow down. Mouse is confused. What is this maze? And then the waves, and then the triangle. No hierarchy. Let's see. Oh, you gave your mouse depth. Let's see. He's stuck in the box. He's alarmed. You created like an emotion with him. I knew you guys would be really, really good at this. Oh, you gave the mouse a face, Sarah. Oh, your eye goes right to him. And then you decrease the background contrast of the rest, and you move this off to the side so you'd see it last. Nice. And this one is the mouse is experiencing a reading. So mouse reading maze, and then this stuff is way over here on the right. So that proximity affects you probably, if you're meant to see this sooner, it'd probably have to come over here or something. Cool. I'm not gonna go through all of these. These are really fun. I don't know what's happening in that story. Wait, Leo. Oh my God. Your mouse is really alarmed by his brainwaves being read. Okay, yeah, that added emotion too. And I didn't even notice the maze. Oh, there's a maze because you faded it so far into the background, and you gave it orange on this like this nice contrast, a cohesive color scheme. That's actually kind of impressive in a short amount of time. But I hope you guys got that out of it. That like you can really affect the story that's being told just by manipulating the hierarchy. Like forget about the actual graphics and things like that. And having that pop out effect is so important. And this applies to every figure in science. And the fact that a lot of scientists don't know this means that every figure in science is probably harder to understand than it has to be. Cool. Okay. So you stuck with me before the Q&A. I want to show you guys a quick question from Sarah. How do you balance contrast when there is a push for higher contrast for visual accessibility? I get this question every time. It's a really good question contrast wise. I think in terms of color blindness, the contrast effect is good as long as you're not using color contrast. So I usually start out my designs in black and white to make sure I'm just using contrast and not affecting the colors at all. And if you have just background contrast, then you should be okay. Like just dark on light background contrast. If you're designing that way, I think you'll be okay for color blindness accessibility, but it doesn't help you with the other kinds of accessibility. And so there isn't a great answer to this. We did a study on the accessibility of scientific presentations and scientific posters. And the number one requested accessibility feature across people with different disabilities was being able to access the content at home, being able to have a copy of the poster to blow up later, having a copy of the presentation that they can like rewind, or whatever. And so I thought that was interesting that like there are so many interlocking and conflicting disabilities that you have to design for, that I thought that it was interesting that the unifying thing was like let people use their own tools and give them the time to use it. That's not a perfect answer. It's because your question is still really valid and I'm still working on it, but that's where I'm at right now. Yeah, empower the people. Exactly. And there are things you can do, like what I showed earlier about the multi-channel processing. You can imagine like somebody without one of those channels, right? You want to have all of them. And so something like closed captioning matching exactly the speaker's words or something like that would actually still maintain that flow between your inside voice and the speaker's voice, but still be accessible. Closed captions like that, I think it can help a lot. But anyway, there's a lot of things we can do. It's still developing. It's a great question. I have a study on that I can send you that we did a poster on. Incidentally, guess which poster design was rated the most accessible? Better Poster version 1. All right. Again, all I can do is collect data. Better Poster with the big graph was rated the most accessible poster. So now that you've stuck with me in the last few minutes here, I want to kind of give you guys some hope. Because I started out with showing you the wall of text and these 300-year-old article designs for scientific articles. And I want to show you sort of that hope is on the way. So the question is like, if we were designing scientific articles with all the modern technology available to us, what would they look like? And that's my day job. So when Better Poster first went viral, people asked me like, how can we design articles? And I was like, I can't do it by myself. Like you need a team, you need technology, you need funding or whatever, and like to fix publishing. And that's where I work. So we have a really, really talented team at Curvenote, and we have this really great open source technology, and we're working every day to improve the design of scientific articles and scientific publishing. And I want to show you kind of some of the stuff that's coming out of that. So what comes after this, after the 300 years of the tyranny of the walls of text? Probably something like this. What you're seeing here, and I've got a video of this, is a 1 terabyte image of a mouse brain embedded in a scientific article where you can zoom infinitely. And I'm going to find this because it's so cool. So this is a zebrafish, and you can zoom in to this 1 terabyte image, and it keeps loading and increasing the resolution. And so you can get to like these individual like cell, I guess it's like the cells or whatever. I think these are, I don't know what part of the zebrafish this is, but if you watch the how far of a zoom works, this isn't like a video really. It's embedding the full microscope image, like a terabyte big, and letting you explore it right inside the article. So back to like how much magic of science does this make you feel? Like being able to zoom into this zebrafish embryo, or like if I could find you the video of this one, you'd be able to see, I think, individual neurons right inside the article. Like that's like a 10, right? And building that technology into the articles. And then we have like these journals, or what you're seeing now is sort of a self-publishing revolution in science, where now you can create your own scientific journal with state-of-the-art reading features that sort of outgun the big journals. So the question that the CEO of Curvenote asked me when I joined that kind of still haunts me is, if you can publish your science in a format that is more engaging and easier to learn from than the journal can publish your science as, why do you need the journal? And if peer review can improve too, why do you need the journal? And increasingly, the answer is going to be, I think you don't. You'll have people self-publishing more. You'll have these boutique journals where we're going to empower these experts. Like this is an example of elemental microscopy, some of the best microscope scientists in the world. And they're just publishing their own journal, right? They'll start their own, they have their own community. They'll publish these interactive computational notebooks that are more reproducible, that are more interactive, that have this leading edge science. And they don't have to wait on the big journal to throw up a PDF in 2 years. They can get it out right now. So this kind of change is really coming, and there's way more demos that I think I'll be able to show over the next year because we're going public with more stuff. But anyway, thank you guys for sticking with me. The company I work for is Curvenote. We're redesigning scientific publishing, and a lot of it is open source, led by scientists. That's why I show for them, because for as much as I believe in changing scientific posters and design, the CEO of Curvenote, he's like that with publishing. I'll die teaching scientists design. He will die trying to fix publishing. And hopefully that'll be after a long life of fixing it. And if you are interested in this design for scientist stuff, you can come hang out at Science UX. So we just help Doctors Without Borders do a poster template, which I'm really proud of. We just sort of do projects trying to get better designs out that can scale across science. And lastly, I have a YouTube channel that I post on sometimes. Okay, thanks for being with me. Sorry, it's a little late for me. It's 2 a.m. for me, so a little loopy, but thanks for being here, guys. And if you have questions, I'll stay awake as long as I can.
Yeah, thank you so much, Mike. This is so much fun. This was just great. And thank you everyone for playing along with Mike's game as well. It was wonderful to see all of your artwork. We have some questions. I did have one student who submitted a question ahead of time, and I wanted to give you that first, which is they were wondering, you kind of talked about what some 30% of people reject the better poster. And we've talked about how sometimes there's rules for conferences about what kind of poster they can create. But what would you say is just kind of the overall biggest barrier to people implementing a better poster style of poster?
This. And like when Better Poster first came out, I was like, I think we only got like 10 seconds to reach people with a finding when they walk by. Now that I've been studying posters for 5 years, I think it's more like 4 to 6 seconds. Like I think it didn't go far enough. And like, that's my, I think people aren't ready for the tiny amount of information people read on posters. Like I've done studies of like how long people, like I've sat there and like had to measure traffic to posters and things like that. It's still like a lot of pilots and things like that. But if you were to ask me off the cuff, I would say, I remember seeing like when I'm trying to figure out how long people spend with posters, the most interested attendee I saw who was just like dialed into a poster, right? Spent a minute and a half with it. There's 10 minutes of content on that poster, right? And like, I think people just aren't ready for how much less content is realistic. But the biggest barrier is this. And that's the mistake. I remember where I was when I made this mistake when this first Better Poster came out. So you remember the first Better Poster didn't have the graph. If you can imagine this with just the main finding in the middle, that's what people objected to. And I was sitting in this room showing off the first Better Poster cartoon before it went viral to my PhD program. And this one brilliant grad student, Jenna Van Foster, I will always give her credit for this, was like, hey, you should add a graph. I think it would help because it'd feel more like, sciencey. And I was like, nah, I don't have time or whatever. And if I had done that, if I had just added the graph and listened to Jenna, it would have saved me 90% of that hate mail. So I really think it's this. I think it's that complexity effect. There's some real objections too. That first design's not perfect. Like maybe we need the title really far up. Maybe we need better ways to really quickly process the methods, right? Almost very nearly 100% of the objections to Better Poster are add this, add that, add this, add that. And I'm not convinced people will read it if I add it. So yeah, I think if I were to recommend right now, just use the current Better Poster, the version 2. Sorry, I'm jumping around here again, 2 a.m. But this one or this one, no, it's just like no objections. And so because it hits that midpoint. And that's me being cynical. There's still problems with the design. It's not a perfect design, but I really think that was most of it. And like I've seen people go ahead. Sorry.
Oh, I was going to say, it makes me think to 2 different things. One is we had another person whose background was in graphic design, and he was talking about emotion and bringing up emotion, whether it's curiosity, whether it's awe. And if you can tap into emotion, then you become more memorable from our psychology research. But then it also makes me think of a question which Dee Dee had passed on to me, one of our students, which was asking kind of along the lines of identity as a scientist.
Yeah,
And
should
the
I?
language of science is charts and complexity. And by taking that away, does it almost tap into their identity? And I'll let you build off of that, Dee Dee.
Yeah, I can just spell it out. So the
Please.
question is like, how do you overcome the fear of scientists to look too pedestrian when they do the simplified poster? And you probably know the little anecdote from Albert Einstein who said he can write the essence of his life on a postage stamp. But I don't know if that is something that works, or are people like, no, everybody thinks I'm going to be too simplistic if I don't have the wall of text. What do you use to convince them?
I use this design. I use a midpoint design. I love that quote from Einstein. I never heard that. And I think you're probably right about the identity. I've never thought of that. I know there's something called cognitive ease, which is like, if you show like that emotional point, if you look at these two designs, the one on the left feels more rigorous. It feels more scientific, right? That we confuse, even if it was just movie quotes, like even if it was just the smaller font size, we confuse that emotion of density with like rigor, and that scientific identity, right? It's just terrible design. It's just, I think you're right about the identity. I'm sure that is. What kills me is when scientists are like, scientists shouldn't be emotional, therefore we should be a wall of text. And I'm like, you want the wall of text because of the emotion it makes you feel. It makes you feel like a rigorous scientist or whatever. And you look at the wall of text and you're like, that person did a lot of work, right? Like, even though you didn't read anything, even though they probably copy and paste it, right? Even though it's harder to create a simpler poster, it takes like more concentration to boil something down. Like, yeah, I don't know how to overcome it. The only way I got is to cheat and just put a little bit more density feeling on there. So if I can make it feel a little bit more dense, but still get the communication through. Honestly, the simplest thing you can do is just add a takeaway title. So if you remember that the human eye tracking demo, or this one, so you notice this title on the right says text analysis can predict social conflict in teams. That's like a declarative title. It's like a takeaway. That's the simplest change I can suggest to a poster, and then make the rest of it a wall of text. But if you just put that takeaway title at the top, at least people can learn something from every poster. And I can usually convince people to move their authors down or make them smaller and leave that negative space as long as they have the rest of it. So Dee Dee, I wish I had the answer. You've given me help. You've helped me with the identity thing, because the identity is the most powerful thing in psychology, probably. So any other suggestions, please send them my way.
Well, I was going to say that I'm a big STEM person and always refer to math as the language of science a lot of the time. And so a chart means that you're speaking the math of science, not just words. And so getting those charts and graphs on there shows that you've got the bona fides to be a scientist, perhaps. Well,
100%. And put them on there. Make them big.
Yeah, that's right. Well, I'm going to throw a quick link in the chat and just remind everyone, we have 2 more visual science communication seminars, and one is 2 weeks from now, and the other is 4 weeks from now. I'd say same bat time, same bat channel, but because Arizona does not participate in the changing of time zones, if you live outside of Arizona or in a place where time changes, come November, depending on what country you're in, because different countries change at different times, we might be 1 hour off of when we're meeting right now. So next week, Science Meets Art, Sparking Curiosity Through Creativity. Shiloh Fontes, the Planetarium and Technology and Design Manager at Flandreau. She has a Master of Arts in Arts and Visual Cultural Education, Museums and Communities, and she's working towards a PhD in Applied Intercultural Art Research. So we hope you can join us again. All of these talks are free. We're always looking for new speakers for future semesters. And in fact, Mike was recommended by one of his collaborators, Zen, who is also involved in the Better Posters movement and was so kind as to do an introduction for me. So I thank everyone again. And Mike, if you want to throw your email address into the chat, or whatever best way there is for folks to follow up with you, I'd highly encourage it. Mike's a really good guy and actually responds to emails and is on some other social media networks. And sadly, I can't let today's meeting go on and on because I got to take Choya, the acrobatic dog, into the vet. So We will close this session for now. Thank you so much for joining us, Mike. Thank you for staying up at this horrible hour of the morning, and hope to see everyone again in 2 weeks. Have a great day, everybody.
Thanks, y'all. Have a good one.